the different components we're going over, and then it'll correspond to the videos. There's a whole video segment on how to build a table, like the first things we're doing. Oh, I didn't realize it's transcribing, so let's stop that. Okay, let me share the screen. I think I've found a new way to share screens that might work better. All right, do you guys see the state of normalization exercise sheet? All right, yeah. All right, Gord, you're going to be my thumbs up person, my troubleshooter. So basically, here's the answer. Basically, what you're doing is taking the 3 normalization principles and breaking things out so that it makes more sense in organizing information. And it seems like a lot of tables, but that's the reality of how you would organize information to make sure you have integrity. And this is a way to reduce errors and redundancies. So basically, with A by X sampling events, you have the main table, which is the observation. So there's always a lifter ID or a sampling ID. There should be a date. Was the original file, was the date decomposed? Because that's a topic I really want to talk about, and I'm really adamant about it. And there are people that argue this, and I'm going to spend a moment to think about that. Most of us will query or ask questions from the data, and we're going to look at it by year or month, but we don't really care about the day for the most part, unless you're doing temperature data or things like that.
There was a month, day, and year column separately.
So Patty really observed this well, and this was real data. Did you notice what happens? So date, I'm gonna define what a date is. Date is a measurement of change. My chemistry teacher in high school told us that, and I thought, well, yeah, I don't know how to define time. So measurement of change. So it's a measurement. So when you take a date and decompose it into 3 fields, what are those 3 fields? They've become integers, right? Does that make sense? When you store data in cells and fields, so we're using Excel, but the same holds true with databases. And the difference between a database and Excel is these are just numbers. In a database, you're defining what each field is, and we're going to talk about that. Like right now, this sheet here, they could be general. Like if you look under format, you can make it a general date. It could be text. So the reason why you don't want date decomposed is because of the errors that are possible. I dealt with the entire Creel data for Michigan DNR from the 80s until the present, and they decompose date. And those, I think, from our surveys. And the problem is when they key punch, which is what they used to do, you're going to have, every time you enter data, there's always going to be potential errors. So you can have a month 14 or something like that. So that's why. And here you can see an issue there, right? There's an error that's probably difficult to capture sometimes. We'll talk about it. I just noticed that. Do you get 2989? Well, I don't know if these data are from Starfleet, I guess, but it's probably a key punch error. And we can talk about ways to trap things like that. Does that make sense about the date field? Most of our questions are going to be year. However, there's a way to do that to maintain the integrity of the way you store data, because if you decompose it, then they're integers. It'd be like taking length, whatever. Where's the card 3? You're taking this. Well, I want to break that into 3 fields. You'll have a 2, which is a 100 millimeter field. So that would be, it's kind of, it doesn't make sense. And it is convenient, but that's not how you store data, but that's how you would feed out data when you have data requests and things like that. All right, hopefully that we want to belabor that. So I don't want to spend more time on that, but you can see basically with each table, you're going to normalize basically group data types that are together. So fundamentally, in a lot of biological sampling, you're going to have like 3 basic tables, as I mentioned last time. There's going to have the abiotic spatial thing. So then here you have the spatial components and also the habitat measures like depth, which we're going to break out today in our access exercise. We're going to defer the normalization, and we'll talk about that, and I'll show you ways to do that in access. But you can see now then you would code your sampling information. You always start at the finest scale. In my opinion, they're a set of coordinates, and then you can have attributes related to that. This could have, as I mentioned, you can have congressional district. The planetary code's not here. By the way, we are on a Class M planet, just for your information. And then you can have gear types, right? So these are typical GillNet type attributes, but you can also have electrofishing, acoustic sounder, bottom trawl, midwater trawl, and things like that. In our data, and probably Wisconsin DNR data, we had commercial operators that we contracted to sample. So you'll have legacy things like that. And then it's really important in the way we sample is to assign what the purpose of the survey and project is. So that's what project code is. So then you can see the typical surveys. Most of my examples are going to center around Great Lakes sampling and GillNet surveys. So chime in if you see how another type of survey would not fit in, and I can help you with that. The only thing I can't really address heavily with, like, we're using Microsoft Access, is really data dense type data sets like acoustic telemetry and a lot of spatial data. Those need to go to the heavy duty, the varsity level database, which is SQL or SQL. And what we're doing with Access is really running on SQL or SQL language, but it's made in an interface like Office products to make it really simple for someone like me, which I do enough coding and I didn't really want to get into SQL codes. But if you start having large data sets, you're going to have to go varsity to SQL, but the foundations here will help set you up with that. And then, the other one, the biological tables really are individual observations. Anytime you do a measurement on a fish, such as a single length, goes here. But if you start counting them or weighing them, they should go here. And then there's all these other attributes like fin clip. And then we'll talk later on about, so this is the core of your database, core of your data, that's typical in biological samplings. The core is 3 tables, but then you have other tables that start building out. So these are code tables, but with a biological sampling, you have basically secondary tables or derivative tables that are also measurements, but they're post-processed generally. For example, age assessment is done later. So then you have tables that are storing biological information. And then one thing you can do that is a really challenge is to deal with mark recapture data. And that is really complex, but I figured out a solution for that. And basically you would do derivative tables, and then down the road, we can talk a little bit more about mark recapture and how to deal with that in sampling events and the concepts, because there's multiple categories. If you guys ever had mark recapture, the bird banding type thing, there's all these different type of events and histories. It's longitudinal, and there are ways to deal with that in the data set. All right.
Sean,
So,
could you expand?
Yes.
Could you expand more on like why you keep the age in a separate table?
Yes, that's a great question. So let me ask you, let's say you have 2 age assessments on a fish. How would you do that in a, all right, let me share this again.
Do you mean like two different ways of aging on the same fish?
Yeah, for example, in a lot of programs, people will do, okay, I don't think the sharing thing is, there we go. Is it working?
Mm-hmm.
So I'm going to overwrite this. So this is what conventionally people that look at the flat Earth look at that.
Mm-hmm.
So let's say you have 10 measurements of age. Do you just keep growing out to the right? That violates the normalization. And how would you summarize that? For example, let's say you want to calculate the average of those 2 fields. We're not using Excel. And then let's say there's 3 fish. One of them has 10 ages. One of them has 5. How would you have a bunch of empty spaces? So that's not an efficient way to store data, and it's limiting, right? Let's say you have 1,000 measurements of something, right? So repeated information has to be decomposed, and normalization would create that here. In our program, We don't, in our production age assessments, we only do one age, but we also have a process where we have staff go through and do quality control measures on ages for calibration. So they'll do the
Hmm.
same age structure, like for fish ID 1, that'll be measured a few hundred times over many years. So the
Mm.
way to store that would be to come down here, and then we would categorize what the purpose of the age assessment is. If it's a final assessment or if it's a quality control. So there's different ways you would store data. Does that
Mm.
make sense? And that would be the
Yeah.
same for if you're weighing gonads. Let's say you're doing a reproductive study and you're extracting eggs, and then you section the ovary like into 10 pieces. Would you just have 10 fields going across, or would you have a table? Those are, let's just say you do that for a living for, all your years. You're going to section ovaries forever, and you're going to do that for many species. Then you would build it out so that you would have multiple measures. So fish number 1 would have 10 sections of that ovary, and there'd be an ovarian weight, right? Does that make sense? Or in an account?
Yeah.
Whereas if you build it out to the right, then it's just going to go on forever. And then what do you do if you're doing age and ovarian weight or something like that?
Hmm.
Does that make sense?
Yeah. And just to follow up, we typically only like have one measure of age. So if it has a coded wire tag, we'll use the coded wire tag. But if it doesn't, then we'll use the otolith. So the coded wire tag field would be a column in card 3, right? Or would that be broken out with the card 3 age table if you're following the.
It's an age assignment. So the CodaWare tag is two things. One, it's a tag. So then there would be a CodaWare tag in the field.
Mhm.
Can you guys see? I don't mean to, I'm just going to give you an example of, so you would have age structure. So this 255, this is 1999. This 255 is a CodaWire tag age. This fish had 3 age assignments because we wanted a reference collection developed. So 0 is a scale. This is in 99. So they did a 6 on the scale. This otolith got another year. CodaWare tag was 6. So let's say you have, like, you're in a program where you guys assess ages twice on each fish. I mean, you can see how that would grow out to the right if you flat filed it, right? So this is a normalization approach. Does that make sense? Like, you guys are dealing with fin clips and CodaWare tag. We got out of that many years ago, but there's a lot of value in that. And when you transition to wild fish, so I urge you to think about um, looking at the relationship between age structures and the known age, which is rare. I used to send these out
Mhm.
to your Alpina station to get the CodaWare tag age. And then, for example, this fish was CodaWare tagged. If you go to the card 3, there would be a fin clip. And then I have a stocking table. I mean, I don't want to get into the weeds here, but then I think I have a stocking table that came from the stocking database that tell me what that fin clip assignment and the year class, right? So then you could
Mhm.
do age comparisons to verify things. And that's
Okay.
where that age came from. It was basically, I did a lookup table to the stocking database and made an assignment of age 6 for that fish as fin clip or whatever the hell.
Mhm.
Um, does that make sense?
Yeah. Yeah.
And you can see in the early days, we were doing this because we wanted to build up that relationship. So, in you guys in those lakes, I would suggest that because the wild fish are coming. Um, all right. Wait, is this, am I sharing this? I can't even tell because the red line. Okay. Yeah, I think so. All right. Did that answer that question?
Yeah, I might follow up with you on more details about our specific case, but in general, yes.
So, anytime with repeated measurements, you got to start thinking about going down into a table versus going
Mhm.
across. It's rare that you
Mhm.
go across, with a few exceptions. We do make exceptions to the normalization rule because we can think down the road, and sometimes we make mistakes with this, and it's fine. But some people just think it's never going to change. So a common one besides age is they'll do tag 1 and tag 2, right? If it's double tagged or if it's recaptured. If you guys do mark recapture, it gets really complicated because it's recapture release, recapture mortality. That fish is going to show up again as a different observation in a different catch event. But then you want to track that fish through your data series because it's the same fish, but it's 2 sampling events or 2 observations of that fish. So, but the idea is that you want to normalize so that you can get to the information, and so basically the rule is you don't grow out information that are kind of repeated measurements to the right. The measurements for each field should be kind of unique, right?
Right. My other question to you before you leave this page, I noticed that all the inch stuff went away. So like the number of fish in each inch category.
Yeah. And those are real data. So what happened in the old days, let me share that. Actually, I wanted to touch on that. So the card 2, okay, are we on this?
It's showing a sheet with like highlights on some columns.
Yeah, so the inch groups are over here. So I don't know if I should magnify it. So this is a convention. Hopefully that doesn't still occur. So this is summary information. So if you guys, one of you can remind me, one of the normalization rules is you don't do computations. And that's what this really is these were inch groups. What they did is a length frequency measurement in storing the data. And it's one thing if you're sampling, let's say you trawl up a bunch of fish and then you just count the number in each inch group. That would kind of go into this type of thing. But again, you would go downwards. Can you guys throw out how you would normalize that? Because let's say your inch group 1 was 100 millimeters. And then this other agency or further down the road, the inch group 1 or length group 1 was 10 inches, right? So you have mixed measures. So you should define what 1 is. I don't even know what the hell that is. And then the other one, I think, is a count. If I look at the field definition, it's supposed to be a count. I don't know why it's repeat. Oh, number 1. So what it is inch group 1, whatever that was, had a count. So here they would code that inch group. But the way you would do that is to bring it down this way. Right? You would code it so that you don't have normalization. Then you would reduce the number of fields, right? Does that make sense? And in fact, you don't really want to do this because if you're already measuring a length, this is a simple rule, and you basically go to the card 3. If the card 3 just has a length and a species and a mesh assignment, that's enough measurements to qualify to be an observation. When you do these aggregate things, I think it becomes a mess because sometimes in a program you're going to subsample, you get 2,000 of them. You're going to measure the length on some subset of them and have more details on others. Then these counts, are these counts of the ones you didn't measure or the ones you did measure? So historically, most of the agencies, this would be the total catch by inch group. So it's a summary of your data. The problem is when you do corrections, for example, some of the lengths were wrong that were measured on the card 3, or they were assigned to the wrong lift, then these quantities aren't updated because the database doesn't know that the catch, there was an error and it's reapportioned to here. And if you work with data from the past or other agencies, a lot of times I can guarantee you numbers don't always match. And it's because of these type of violations you do. So you don't want to do summary things like that. And the reason these are in yellow, these are the most important fields you would want to have in the card 2, that all you would need. And again, if you only count or weigh fish, it goes into card 2. As soon as you measure a length, it should go to card 3 because you have 3 fields related to that fish measurement. You have an inch group or a measurement, you have a species assignment, then you have a mesh, and then you have a lift ID. So that qualifies to go in card 3. And these ones that are left in white are just redundant, information that really shouldn't be here. And a lot of historic data with most agencies will do this. This date format is actually the old mainframe computer coding. And there's some sort of format, like the 2 might be the the last digit of the year or something. I forget. But yeah, there's all kinds of weird stuff you guys don't have to deal with. Did that make sense?
So it's a little hard to understand since it's all zeros right now. Does it mean like for each ID number, you'd have inch group 18, 19, or wait, for each ID number, so say 971, you'd have each inch group and then the count next to it?
Yes, that's what they would do. So what they
Okay.
historically do, they would have like a 10 and then 11 and 12, right? But you can already
Yeah.
see there'd be like major errors. I'm cleaning my language up. They'll do this, and then you'll be like, wait a minute, you just missed a number. Where's 11? And every type of wrong thing you're going to see, and you're going to spend weeks wondering what happened, going back to data sheets that are on pallets. And the basic thing is, I'm going to tell you, don't do this. If you're trawling and you get 2,000 suckers in a gill net, as soon as you measure a length, I'll show you easy ways to enter. You can enter 100 lengths in probably 10 minutes on ship. You're not gonna. You let the computer count for you. We suck at doing math. We need in our heads, and I'm just telling you, we are not going to do this. We're humans. Okay. And if the machine makes an error, then there's a logical reason for that, and it's usually because we screwed it up. Look at ChatGPT, man. That's all the weird stuff that comes out of that's human induced. So does that make sense? The fields in card 2 is either, so this is an old thing where they did commercial monitoring. It's round weight or dressed weight, that means they were gutted by the commercial operator. So that's the weight without the digestive tract. So there's a relationship with that you guys can build. It's total number. So you could basically, there's different ways to code this, and we don't want to get into the weeds of it, and it'll be intuitive to you as you do this a little bit more. For example, if you have a program that has mixed compositions, so this total, you can just assign it as quantity measured, right? So this 31 could either be 31 fish, right, units, so that would be count, or biomass, right? So that's 1 kilo or something like that, and standardize your units. If you deal with interagency data, which some of you are going to do, where you're going to get stuff from the tribes and the state and the feds, then you might want to add, what their units are. I really just convert it. It's not that hard to do. It's automatically done. That way you have less fields and you can always ship it back in kilos or furlongs or whatever the hell units they use. Does that make sense? It's a lot. Like, I hate to get into the weeds too much. That's why I'm trying to keep it simple with these examples. But as you progress with this, you'll start seeing, oh yeah, if I apply the normalization rule, it's logically done in this way. It has to have a justification. So if you have a lot of agencies that have mixed units, and you would do this. But if it's just like, you wouldn't do this if your own program just does it by counts, then you don't have to worry about that. But, a lot of us will do gillnet catches, or they'll do bottom trawl surveys, which is usually by mass if you have a giant deck full of fish. So it depends on how you sample stuff, but there are solutions to do that in a normalization way. Hopefully that made sense. It'll come as you play with the data, it'll start becoming more intuitive, and if not, just ask me. All right. Any more questions about the normalization process and that example? And then you guys can email me more questions in detail. I wanted to give you real life data that you're going to face out there. But if you're building it from scratch, it's a lot simpler if you just started the survey program on your own. And that's going to be kind of the way I'm going to teach you to some extent. All right. Let's stop sharing. All right. So right now, I'm going to basically show you how we're going to start to build a database from start. And we're going to import data. So the data files that I sent you, the card 1, 2, and 3, and it's also on the Google Drive, I'm going to use those as examples on how to do this. And again, I have videos that go through this process you can look at later in case I miss anything. So I'm going to figure out a way to share a screen. All right. I lost my sharing thing. Are you guys seeing the MX, this right here with the access? I'm going to create a blank database. So I would like you guys to go on your desktops if you guys have access and go ahead and open that. And there'll be various versions. So what we're going to do is start with a blank database. And you guys can name it whatever you want. I'm just going to do EM and then just going to put it in the class directory here. Just chime in if I'm going too fast. So when you open access, it's going to automatically create a table and it's going to assume you want an ID. So in access, I'm going to go over in the environment. On the left side, there's a panel that shows you the different components of a database. So let's see if there's all there. So in a database, the major objects and where the real information are in tables. And then the more virtual things that really doesn't have anything hard storage, they're just lines of code and interfaces are the queries. Queries, again, are the questions you would ask. So that's your, so if we look at this as a bank, the tables are the vaults where all the information or money is located. The queries are the teller that you would walk up to and ask for the information. So we're going to create queries to ask information. And at the same place, we can do other transactions. And I'll go over the different types of queries. So the most fundamental query is asking a question about the data. How many fish did I catch? What sizes they are? But the query is also the interface so to correct data or to add data. So if you want to make a deposit in the bank, you want to append data, you would use a query to bring in data and put it in there. And then there's also an import function in the database and an export function that basically is a separate component from these things, which is typical in most softwares, bringing in files. And I'll show you how that works. And forms are a place where you would create a user-friendly interface to access information and enter data. And we'll talk about that after we go through tables and queries. So you guys can create a simple data entry form. And I'm going to use basic fishery survey as an example. And then I don't use this very much, but if you have reports that are basically standardized, for example, I create catch reports for my vessel captains to use so that each season they'll print off these reports. It'll have the total number of catch and species and effort and depth and all this crap in a nice format, like a paper report that they can look at when they designed this year's survey, so they can know how to schedule the stations for a reasonable work day. So if we have like 3 stations that have high catches, they're going to spread them out in different days and things like that. And it could be used for other things too. If you do tag return letters, or if you want to write reports of like catch summaries and surveys, you can do that here. But I think most of us are migrating to R and using R markup to do a lot of that nicer way to present the information. All right, so let's go back to table. So by default, when you open access, it's going to name the table 1, and it's going to assign an ID because in a database table, you have to have a key. So it makes an assignment of that. And then it just doesn't know what other fields you want. And so in the left corner are the different views of what you have open. So right now we're looking at a table at a sheet view. So database tables are set up like Excel, except they have more explicit requirements for what goes into each field and cell. And so to look at that, we want to look at the design view. And it's asking you to enable table name. And right now we're just going to leave it as table 1, just as an example. All So in a table, if we go back to the sheet view, again, if you recall from the first seminar, these are all fields, and then these are records. So there are no records, but there's potential for any number of fields you want. And so it automatically, because of database normalization, it creates a key and it's an ID. So in the context of the way we do it, if we look at this as a card one sampling event, it's basically creating a lift ID. And so with fields, then it has an explicit definition of data types. So on the Google Drive, there is a sheet that describes the different types of data types. And let's see if I can bring that to this sheet. Is that showing up the date? I think it is. So it gives you an idea of the definition of the different data types. And we're going to go back to the, and if you click on it, that Word file will tell you what these all mean. So text fields are what you would do for notations, or characters for like species characters. Most of the time, we're going to deal with the number field and the date field, date and time field. I don't think we're going to deal with currencies. And then there's other fields you can get into, and we'll talk about that later. And then we're going to talk a little bit about auto numbering, in that we want to assign keys for every single table, but most of the time we're not going to use auto number because, for example, if we have a database code table for species, those are probably already established in your agency. So you're not going to use auto number. And there's a whole thing about using auto number that can be kind of complex, in that if you have, it's basically auto incrementing your data from from 0 or 1. Then if you delete data, it'll just omit those numbers. So it's basically assigning a social security number to a record. And I'll show you an example, a few examples where we want auto number used. And that's in a case where we have a high volume of data. So it would be the card 3 individual fish measurements. And we'll talk about that a little bit more. So these are the different formats. And another way, so if we go to number, there's going to be attributes of this field down at the bottom. There's general and lookup. So we're not going to get into every bit of this because we're not going to get into the weeds of it. I'm going to show you the most basic things. And a lot of this is you're going to learn through the process of denial and error. Basically, once we get the basics set up, you're going to start playing around with this stuff to see what it does. And always make, if you have your real data, you want to make copies, but we're going to use example data, and then you'll start learning what these all do. But for a basic field, you're going to have a name of the field. So let's say we want to call this lift ID. You would just go in and type it there, and we want that to be a number. And then there's different number formats. So every type of number format in the database has a memory associated with it. For example, the byte is the least memory intensive, but it has a range of values that you can use. So on the right, it gives you kind of an example of attributes that have to be assigned for an auto number. And if you're in this field, you can hit F1. Hopefully my internet's working. It's supposed to bring up what the definition of a byte is. And if not, I'll send you the information, and it doesn't seem to be working. Right, we're going to go back. So there are like definitions of what byte and how much memory it is. Integer, let's try that again. All right, it's not working. All right, we're doing this the slow way. So there are definitions for the different, so numbers, hopefully it comes down here and gives you the attributes of number. Sorry, I wish I had this working. Let's see. I'm not going to get into this too much. So the type of numbers, whether it's an integer, byte, or long integer, single or double decimals or different levels of precision. So a double number is the most memory intensive. If I recall right, it requires 8 bytes of memory. So if you store all your information as double, it eats up more memory in storing your data. So a double basically goes from plus or minus, it's almost like to infinity. So if you're just doing like sea lamprey wounding, for example, it's a common thing you measure in the Great Lakes. The most wounds you'll see on a single fish are maybe 6 or 7. So you wouldn't waste memory by assigning the field site as a double. In fact, if it's a count, it's an integer value, which is a lot less memory. So these are higher, progress from lowest memory to really high memory. So you basically want to set that as an integer, for example, or even a byte. A byte goes from 0 to 256. So a sea lamprey wound, which only goes up to 8 wounds per fish, you would set that as a byte. One thing I'm going to really some of these others, and then you can establish how many decimals. Like a byte would not have a decimal value, so you just leave it as auto. A lot of this you would leave as default, except one thing I don't like is it assigns default zeros. And again, we talked a bit about really being explicit about how you store information. So you want them to be null unless there's a value or a measurement, with a few exceptions. For example, if we're talking about sea lamprey wounding, anytime we have that in our surveys, we are required to measure that. So here's an opportunity where you would actually leave it as a default 0, because let's say in sea lamprey wounding, about 80% of the time, most of the time, there's 0. So you can provide a default 0, and then you would only change that if you observe a sea lamprey wound. So that's one exception to having this default 0 there. But normally I would just get rid of that so that you don't have a bunch of zeros. So the lift ID, we're going to assign it as a number as a byte. So it's just a small number. And then here you can just basically say lift ID. And this would be the global primary key in the database. And the reason I'm saying global is this database is based on surveys, and it has to be assigned a lift ID. So we're going to use the context of all of your surveys or GillNet surveys. And in order for anything to exist, for a fish to exist, it had to have started with an observation of a GillNet lift. So that's why it's a global feature. It's going to ask you to change. So right now there are no values. So you basically can have lift ID 1, lift ID 2, lift ID 3. So one of the things we do in sampling, right, we have to have a primary key. So we can't have 2 lift ID 3s, right? That's an error. You can't have 2 of the sampling events with the same lift ID. You want that to be unique in your database. And the reason it allowed that is because there's no primary key set. You're not making this so that it's a key. So in a database, once you establish a table, you have to define the primary key. If you remember our normalization steps, you have to establish a key. And so what we would do is set that as a key. And if you saw earlier, when you create a default table, it automatically did that. Does that make sense so far? It might make more sense once we get real data in here, and I'm going to show you how to import the actual survey data we have. So I'm going to assign lift ID as our primary key, because you can't have 3 sampling event 3s in global history. So I'm going to hit yes. So whenever you have a violation, right, that's the integrity here that occurs in a database, and Excel would never do this for you, is that it says the changes you made was not successful because you have duplicate values in the index, primary key, or relationship. So we'll talk about index and relationships a bit later. They're related to creating unique pieces of information to reduce redundancy and errors in your database, but we'll just focus on the primary key. As you recall, we have to have a primary key in each table, and we're establishing from scratch what basically a survey would do. So we're trying to get the reason this is that way, so it won't assign the key. So we're going to go back to it. I took the key off, and the reason is because I have 2 3s, right? So basically that should have been a 4. So now we're going to go back and assign a key, and it should work this time. So now that's a key. So now that's established. Let's say we never enter data in tables. We're just doing this as an example. So let's say I enter lift ID 5. So I do 5 again. This is something in Excel will not. Okay. So this is what's called error trapping in the database. So this is why you use a database versus Excel. It doesn't allow, the integrity violations, such as having 2 lift IDs being the same. So in order to fix that, you either delete the record. Okay, so it's not allowing me to delete it. So basically I either have to hit 6, fix it. All right, any questions? Unfortunately, the help thing wasn't doing so. I urge you to basically on your computer, it might work. So if you click on the byte field and you hit F1, it should go to a website to tell you how many bytes and what the range of values for byte. Has anybody been able to do that? Just click on that and hit F1. I don't know why my computer's not working.
Yeah, I got it, John. All the field size properly comes up.
Yeah, so like integer. So I urge you guys to do that. And what I'll do is, I thought I had a file. I'll show you, because we deal with numbers mostly. It'll show you the precision and all the stuff, and you're going to see 10 to the minus 23. It's almost like Avogadro's number or whatever. And does anybody know that? And why? Why do we know that? Professors teach us that for some reason. Well, I guess chemistry. Okay, so that's basics of a table. And again, if you recall, tables are the core of the database. We store our data there, we store our codes there. But most of the time, we're not going to be playing in the tables because we're going to use the other features of the database to bring data in or enter data. So we bring data in through data exchanges. We're going to use queries and import functions. And then when you guys conduct surveys, and if you actually record data on paper, you're going to enter the data through an entry form. A shortcut to doing that is having your entry form on SHIP or in the field where you enter it electronically. And down the road, we'll talk a bit about that in different ways we can do that efficiently and skipping the paper step. All right. And we can come back to a lot of this, I urge you, is basically through trial and denial and error, just trial and playing around with it. And make copies of the data. But what I'm going to give you is an example data set to do that with. So normally we wouldn't create a database from scratch, given we're not starting from time 0, but there may be some instances where you do that. All right, so what I'm going to do is just leave that there. So what we're going to do now is I'm going to import the card 1, card 2, and card 3 data, not the normalization one. But the ones that I gave you as class files, I think I emailed them to you. And so in the menu, there are creates. Here's where you would create components of the database. We're not going to do that right now, but we're actually going to go to external data. And this side of things is for exporting. So basically you could export your information to Excel or text file, or you create PDFs and all this other crap. But what we're going to do is most of the time is we're going to do importing, which is bringing in new data sources. And there's multiple ways we can do that. And the 2 major ways is we're going to bring in from an Excel file, a non-database file. And most of the time you're just going to deal with Excel or text files. But we can also import from databases. And also you can start getting more complex with SQL servers and more, varsity level crap that's out there. DBase is really old school. It's a precursor to Access, and you may have old files that are that way. And so the files that we're importing right now are Excel files. So go ahead, go from file to Excel, and then we're going to map. So we're going to map to where your files are located. And mine are class files. So what I'm going to do, and I'm trying to, I don't know if I could do multiple. I've never done it. I think you have to do one at a time. So I'm going to show you how to import the card 1 because that's the starting point of any survey is the existence. So you hit OK. So I'm going to bring in the LT LM 93 card 1. So that means Lake Trout Survey, Large Mesh, which is their spring survey, 1993 card 1. You see the DBF there? That's a legacy from what those data came from, because in 93 they were using DBase. And no, I'm not that old. I wasn't here in 93. Okay. I'm sure yours works, but I'm having issues with my. All right. I have another source for that. Wow, this is bad if it doesn't work. I've had problems with my computer this week. My R Studio got wrecked and I can't use R. Did it work for you guys to bring in the card 1? Okay. Patty, go ahead. Are you asking a question? Let's see.
I was just trying to give a thumbs up. My bad.
Okay, no worries. This better work. Okay, good. So when you bring the import, it's going to have you format and fix it before you bring it in, and it's going to bring it in as a table. So this is the card 1, and hopefully it's the same file. What you can do is, as part of the import, so what's nice about Access, it has an interface that's more personal and human. All of this can be done in SQL. So those of you that do coding, you can do all this, you know, in the next level. When you do SQL, you're not going to see this type of interface. To me, I like this. I don't want to know more code. So these are the different fields in the card 1, and it's, you know, it's going to have the worksheets, and then there might be named ranges. I never use that feature. So most of the time you're going to bring in is from an Excel or a CSV file. And then these are the things. The ID number is what we use as lift ID. There's date, project code, and all this other stuff. So then you would walk through the wizard. These are called wizards. I like wizards. And basically, it's going to ask you, which you should try to set up. Sometimes you're going to get stuff from other people or your old stuff where there's no field assignments, which you hope there's not, because then how the hell do you know what the stuff is? And in fact, these data didn't have that because they were from the old mainframes, and I had to know what the first field was and things like that. It sucked. So then you walk through each field to basically, you can basically assign attributes to that. I don't mess with this normally, so it automatically assigns the data type as double. Let's see what it does in the next field. So it does recognize that it's date with time. So generally there's a good handshake between Excel and CSV files and Access, and this occurs with most software, but you have to check it, because if your date is not in a proper format, it's going to look funny as an integer. And I don't know what they use for these measurements of time. You know, they have some big number, which is, I don't know, when God started or something like that. Oh, I shouldn't have said that. It's some weird thing. And as you'll see, we'll look at date formats. And this is an area where you'll have a lot of trouble if you deal with a lot of variations in date formats. So you can walk through each field. I don't see any that are assigned as text. So it kind of just assigns it the biggest number possible to capture it. We'll go to the next wizard. So here's a point where it's going to basically ask you if you want to assign a key to the data right off the bat. And normally Access will automatically assign a key because it assumes you don't know anything about normalization and primary keys. But this data set does have a key. So what we would do is choose our own primary key. And by default, it'll grab the first field. So the way those Excel files were formatted, the key was always on the left. It's the lift ID, but it might have been over here. Then you would have to specify that or highlight that field as the key. So if we do that, actually, most of the time I don't do it. So if there was 1,000 records, if I chose that and there was an error, a repeating key, or they used it, there was like a blank cell, like if there's problems with the data, then, you know, it would have issues. So I usually don't assign a primary key, and I clean the data. But we're going to assume that this is right, because if you look at the 3 numbers, they're unique. So they will serve as the primary key. And then next, you can import the table. So what we're going to do is so if you're bringing in data from other agencies, you would code this somehow. But since we're actually going to use this as our foundation as a card one, we're going to basically call this card one abiotic data, right? And then I'm going to hit finish, close. I'm going to get rid of this table one. We don't need that anymore. That was just an example. So everybody out catch up so far? So if you click on that, it's going to go to the sheet view. And it's going to show you the data brought in. And then again, you can go to the design view. Okay, go to home and go to design view. And then again, here, basically, when you import data like this, you got to check everything. So then you look at number. Do you want lift ID to be double, which is 8 bytes of memory? In this case, it doesn't matter. And again, a double can also have decimals. So is your lift ID going to have decimals? We do use decimals for certain things, and besides measurements, and I'll talk about that later. So what I'm going to do is just change this to a long integer. I'm going to assume that the database is going to last forever, and it's going to be a long integer, which I don't know how many digits that is. And it'll capture all the potential lift IDs we're going to have into the future. I don't have this set as an auto number because I'm dealing with a series of numbers that was handed to me. And so basically it's only 4 digits, but it can grow out to 6 or 8 digits in the future. So that's a lot of sampling events. If you notice that when I changed the data type, it asked me, it's going to say you could have data loss. So for example, if you have a bunch of data that came in and there were decimal values and you change it to integer, the data loss would be, it would truncate the decimals. So you really have to be explicit about each of your fields and the type of numbers you want. And that happens a lot where you have, for example, if you bring in lengths that were in millimeters and then they were converted to inches, or vice versa, like millimeters will have decimal millimeters, and it would basically truncate that. And that would matter. Like if you have pounds, decimal pounds, and you truncate that, that would be bad. And I've seen that before. So if you walk through each of these, the date format, here you can format that. And then if you drop the list, there's different ways to format the date. Typically, I use the convention of a short date. And we'll talk about how you're going to do your sampling program. I don't use date and time in one field, even though in concept and theory, an observation does have a date and time event. So when you went to lift that gillnet, in theory, there was a time assignment to that, but I'm going to tell you right now, we're going to violate normalization in that the time should be a separate component because we rarely use the time. And then if you start summarizing by dates with the time in it, it's going to go to the second and it's going to sort out information by that time instead of that day. Just, did that make sense? It's too explicit for our needs. And so basically we would set that as a short date. I'm not going to get into this too much because it really doesn't matter. And I'm going to explain what these fields are before we go to the next step. And we're going to import card 2 and card 3. So you guys can do that while I'm just going over this table if you want, if you could multitask. So this is the lift ID. This is the date of the lift. This is the project code. 307 is our species code for lake trout. So it's a lake trout survey. And we have a station ID. And you can see there's station 16, 18, and 16 again. So that was sampled in 2 different years. Or actually in the same year, station 16. And then what this is site depth 1 and site depth 2. So that's basically the bathymetric depth, the bottom depth. There's another depth that occurs in sampling in that if you do floating gill nets or midwater trawls, or if you do something in the middle of the water column, that would be considered what we call fishing depth or, sampling depth or something like that. So you could make this bathymetric depth. You could put B depth. I just went with what was established earlier, and these are in feet. So this gill net was set between 110 and 138 feet for our spring survey. And then this is the effort in terms of time. It was soaked for 3 nights. Yeah, we we soaked gill nets for 3 nights. It was terrible. And then this is the gear code. So gear code 5 is whatever this type of gear, and we'll talk about the gear code, what that is, because this got normalized to some extent. And then this is our field for gill net length. So that's 1,500 foot gang of net. And then again, I mentioned to you earlier, this is the collector. So for you, if you have multiple personnel or different agencies collecting data or different teams or crews, you can make this collector. Like I just left that as license, but it probably should say collector. So 320 is one of our commercial operators. That's their license number, but the license 0 is us as an agency. So there's different ways to decide who collected it. All right, so I'm just going to leave that, and let's go ahead and go through and make sure you guys can import the other two, card 2 and card 3. So let's do that. So here's a good example where there is no primary key in the card 2 because of the way it's designed. And I'm going to talk to you about how to establish a compound key with the card 2. So go ahead and go through the card 2 and don't assign a primary key, which is most of the time what I do. And then we're going to name this C2. I'll just call it AGG for aggregate. Or I guess we can just call it aggregate and catch. It doesn't matter. So then I'm going to click on that. All right, we're at 10 o'clock. I have this scheduled to 1 or 10:30. I wasn't sure how this is going to take. Is everybody okay hanging on, or does everybody have to leave and I can stop now and we'll continue next time? Okay, I'm just going to keep going. Gord, we're good?
Yeah, I'm good to 10:30.
All right. So that's card 2. I wasn't sure what pace we would be going at. At the workshop, it was a bit different format. So this is what it looks like. It looks pretty good. And we're going to close that. And then let's go ahead and go to importing card 3. We're going to go through. So right now, this card 3 table has, again, no primary key. If you look at the way the data are organized, there's no really unique key. And so this is an example where we want to establish a primary key by auto numbering. So what we'll do is let access do a primary key, a lift ID, but normally when you import data, you're not going to establish the key at the onset. In this example, we're going to do that. And then we're going to call this card 3 like fish data, individual fish data. So I'm going to click on the fish data because that's a really important one. So it created an ID, right? Basically, if you don't have a global primary key for fish data, this is the example where you want auto number to work, because over time, like we probably have 500,000 fish. I don't really want to figure out what the primary key is in the database to make it unique. It's like coming up with social security numbers. I'm just letting the database start from 1. And let's go to the design view quickly. So establishes the key is auto number. So that's what we want. And I'm going to rename it fish ID. And then I'm going to label it as fish primary key. So I want to spend a moment on this. It's really important is that in a card 3 biodata table, you do have to have a unique identifier for every single fish. And the easiest thing to do is use auto number, or if you can also modify the auto number and basically establish a number series, but it's going to grow throughout your program. And so I just usually leave that and don't mess with it. So you can see basically it creates a unique social security number for each fish. And then it has the lift ID assignment, has the species code. And then this is what you do in the field. Either a sample ID, or most surveys and agencies use a scale envelope number assigned to the fish. And here you can see we use repeating values depending on the lift or the year. And that's allowable because you still have the primary key in the database. So in order to know where this fish was collected from versus another fish that is number one, you basically have to have other information to make it unique if you didn't have a primary key. So that lift 971 had a fish scale number 1, and so did 996. So basically in our sampling program, historically, we had repeated field scale numbers. So they weren't unique globally. So that's why you need to have a key, so that in the database, you have to have some way to identify each record and observation of a fish. All right, does that make sense at this point? Any questions about that? So this is an example where you would want a primary key established. And basically, I let the database establish that, so that as you enter more data, it's basically going to create the next one. So let's say we have lift 1000 and we have a lake trout. It basically assigned the next number for a primary key. And well, holy cow, these are in inches. So we'll use an example down the road on how to convert this metric, because I have my database mostly in metric, at least the bio data. Right, any questions at this point? So let's look at these tables quickly and look at normalization. So you can have multiple tables open and go back and forth. So card 3 is one where there's a normalization violation. Can someone tell me how we would, like, what fields make this not normalized? And we'll do it down the road. Any idea which fields? This is something Sarah touched on.
The age.
Yeah, so basically age and age structure, you would want to move to a derivative table and age table. And through queries, I'll show you how to basically normalize this database, but we're going to make an exception at the moment for that. And I don't think there's any other fields here. So right now, one other step before we leave I want done is we're going to finish importing. And I think next time we'll get into queries on how to clean up some of this data and start asking questions from the data. So we have the data tables. Now we need to have the code tables. And we're actually going to create one code table because I didn't include one in that sheet. So there's 2 different database code tables I sent you in Excel. In the last email, I sent you the one for this exercise. And earlier in the first seminar, I think I provided one that had examples of what we use in our station. That's not what we want for this database, because I want you to use the examples for here. That's a lot simpler. So again, we're going to go to external data, new data source from file, go to Excel, and we're going to browse. I got to make sure I grab the right one. I have a feeling I'm going to mess this up. Open. Let's see. Okay. We're going to have to go through. Are you guys getting this? It's going to bring up species code or one of the other tables. I'm going to do it again. Let's see. Do you guys see that DB codes? We're going to bring that one in. And so the first row here, it didn't automatically check that. Those are field names, so we want to assign that. So we're bringing in the species code table. In this case, these are coded so that they're keys, so that the primary code, we're gonna choose our own key. We're gonna assign species code the primary key. Next, and then I'm gonna leave it species code, and hit finish. So that way, any table I have here, if I have the word code, then I know it's a code table. And then I'm going to click on it. So these are all the different species we have in our surveys. And this actually is the same convention that was used by the USGS many years ago that aligned with us, but it's basically different now. Everybody getting there? Bringing in the species code. All right. So we're going to do the exercise again. I want to bring in the other codes that were in that table. For some reason, mine is not showing up. The FinClip code. Has anybody else got the FinClip code working? There we go. You guys should see something like this that has species, fin code, and tag code. What I want you to do now is to bring in the FinClip code. Again, the first field has the field assigned. And again, the FinClip codes, the numbers are primary keys. So we're going to set that as a primary key. Fin code. And then the table's already named fin code because of the sheet name. So click on that, hit OK. And then let's go to the fin code. So basically, it's assigning a numeric code, a key, for the different types of FinClip patterns that are used in the Great Lakes. And I create no clip as 0. That seems intuitive for, unclipped or wild fish. And then here's an example where another agency has a slightly different code system, or it should be similar, but sometimes there's variations and you integrate different codes. In our program, we don't use V's and P's because they sound too alike when we're speeching that on ship. So we say front or rear or back or whatever. So this is left rear, which would be the left pelvic. So it would be LP or no, LV. I don't know. We use front and back on, the fishes that we sample. So there's different conventions. And then let's go back again and import that last code table, which should be tags. And this is an example of how you would do mark recapture. I'm just bringing it in just to show you the example of how to import tables. And I'll talk about the details of how you would organize mark recapture stuff with this approach. But for now, we're not going to dig into it too much. Again, the first field, and the first field is a primary key. So I'm going to set that as a primary key. And those are tag codes. And in this case, if you have a fish that has a CodaWire tag, it would show up here, or it should. Here we go, 202.5. So I think this is a different code system we use. All right. All right. I think I'm going to stop it here and allow some time for questions for the rest of you before we move on. Because that was a lot at once, and then we can have some discussions here. So the next step is basically we brought in the tables. The next step is we have to make it valid by having relationships and connections between them. Because right now they're just independent objects, and then we're going to establish relationships. So that's what makes a true database a database, is to create the relational aspect. And we'll start that next week, I think. Any questions at this point? We can dig into the weeds a little bit about the codes. And so the purpose of the codes is to create efficient data so that you don't have to have all the attributes of gear. And for example, right now, I think maybe I'll make this a homework exercise. I want you to, and I'll email this to everybody else. So right now we don't have a gear code table. So I think for homework, I'm going to have you guys create a gear code table based on what you see in the card 1. All right, it's a really simple exercise. And then think of the context of a GillNet and think about what you want in the gear code table, and you can make up the values. Is that too fuzzy or gray? I'm not hearing a no. Okay. Well, I think I'm going to end it here. If there aren't any questions, I think it's a lot at once, and hopefully the type of information we're messing with is relevant to a lot of the work you guys do. And for the students that are here, it might be a little esoteric, but it can apply to different types of sampling that you guys are going to do. Any questions or issues? Please email me anything that I missed or I should include. But what I'm going to do is kind of send out the assignment, like I mentioned, to everybody to basically create a gear code table. And next week we'll start with connecting the tables and moving on to queries, if that's all right. I'm going to try to keep this at an 1.5 hour format, and hopefully everybody can do this. All right. Any questions, comments? All right. Well, you guys take a look at the stuff and digest it. I'll get the homework assignment sent out, and then all the materials today I will try to get sent out pretty quickly. And then any suggestions for next week's format. But basically what we're going to do is finish up the architecture of the database and start getting into the query section. All right. So have a good weekend, everybody. Hopefully this was a nice lead in.
Thank you, Sean. Have a good weekend.
Yeah, you guys too.